Hello everyone, and welcome back to the BostonSpace VR series. My name is Andrew, and today we're here on the beautiful Martian surface. Mars is a planet that we know quite a bit about. We've sent orbiters here, we've sent rovers like my friend Curiosity here to do science on the ground. We've been here, we've seen it, and we've learned so much. However, today's episode is about a place that we haven't been able to get close enough to really answer a lot of the questions that we have. That would be this star here, of course, our Sun. We are currently in the process of trying to change that. We have a probe on its way to the Sun called the Parker Solar Probe. The Parker Solar Probe just launched last month on August 12th. Let's take a look in case you missed it. The probe launched on a Delta IV Heavy, which is comprised of 3 common boosters. It's a very powerful rocket because you need a lot of power to actually get the probe to the Sun.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the Sun.
As you can see, the launch went off without a hitch. Perfect launch. And now we are on the way to the Sun.
25 seconds.
I'm definitely not an expert on orbital mechanics and orbital physics, but I think I should be able to explain to you why you need such a powerful rocket to get this probe to the Sun. So you have the Sun here in the center, and you have the planets. I'll just draw Earth. This is not to scale. Earth is orbiting the Sun in a big elliptical manner. So, Parker, of course, is launching from Earth, and it will follow the same orbit of Earth until it uses enough of its own energy to slow its orbit down, fall out of the orbit of Earth, and instead come closer to the Sun and make its orbit like this. It's going to make its first closest approach to the Sun on November 5th of 2018, and it should make a total of 24 orbits up through 2025. As I mentioned earlier, there's still a lot we don't understand about how the Sun works. For example, here's the Sun here. We'll call this outside black line the surface of the Sun, and the rest outside is the atmosphere. It turns out that the surface of the Sun is much, much, much cooler than the atmosphere. And up to a certain extent, the further you go out in the atmosphere, the hotter it gets. We don't understand why that happens, so we want to actually go into the atmosphere using Solar Probe and figure out what mechanics make that happen. Another thing we don't fully understand is how the solar winds are so fast. The solar winds are particles, plasma, all sorts of stuff that come off the Sun in all directions out into our solar system. It's actually what causes the aurora borealis here on Earth. When those particles interact with the gases in our atmosphere, we get all sorts of fun purple, green, blue lights up in the northern and southernmost parts of our planet. So these solar winds travel at about 500 miles per second. We don't know what mechanism makes these winds come off of the Sun at such a high rate of speed. So what we want to do is actually go in to where that activity starts to figure out what makes that happen. So as we've learned, the Parker Solar Probe is going to become the spacecraft that gets the closest to the Sun in human history so far. We're going to learn a lot about the Sun. It's going to go into the outer atmosphere of the Sun, learn about what makes the atmosphere so hot, what makes the solar wind so fast, and it's going to learn so many things about how the Sun actually works. Parker Solar Probe is going to make about 24 orbits using Venus as a gravity assist up to 7 times, and it could become the fastest human-made object in history. We should find out. Thank you so much for watching. If you want to learn more about Parker Solar Probe, I highly recommend checking out NASA's website, their YouTube. There's lots of really great content out there that you can check out. And until next time, I'm Andrew. This is Curiosity. Thanks for watching. Bye bye. See you next time.